What's up? I'm Vin, and I'm going to go through the August 2025 Algebra 1 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first up, we have the Part 1 multiple choice. There's 24 questions here, and each one is worth 2 credits. For question 1, we have which expression is equivalent to 100x squared minus 16. So for this one, if we're doing this algebraically, we have to know a difference of 2 squares. When we have a squared minus b squared, this factors nicely to a plus b times a minus b. So for this one, when I look at 100, I say 100 is a perfect square. The square root of 100 is equal to 10. So I just start breaking this down piece by piece. So I'm going to say we're going to have plus or minus in our parentheses. And I do the square root of the first term. So the square root of 100 once again is 10. And then we have x times x makes x squared. So we're going to write an x here and an x here. And then the square root of 16 is 4. So we have our 4 at the end. And now we just look, and this is going to match up with choice 3. Now, let's say you're looking at this and you're like, oh no, that algebra looks difficult, or you just want to check your answer. You could go to the y equals and you could type in the question. So we have 100x squared and then minus 16. And if you wanted to do this at the Regents, you could just type in every answer choice and see which one matches. So when we get to choice 3, when we have 10x minus 4 times 10x plus 4, we type this in and press graph. And notice that the two graphs here completely overlap. If we press second graph and go to the table, notice that all the y values match for each value of x. So that tells us that these two expressions are equal. Question 2, Josie has $2.30 in dimes and quarters. She has 2 more dimes than quarters. Which equation can be used to determine x, the number of quarters she has? So for questions like this, sometimes I have to reread these more than once. And I look at this and I say, okay, x is the number of quarters. So quarters, I'm just going to say over here is x. And then they tell us over here that she has 2 more dimes than quarters. So if she has x quarters and she has 2 more dimes than quarters, that would be x plus 2 dimes. And now we want to know which equation can be used to solve for x. So here we also have to know the value of a quarter. A quarter is worth 25 cents. Okay, so 25 cents is $0.25. And a dime is worth 10 cents. So that's 0.10. So now we just go ahead and build up our equation here. So we're going to say we have 25 cents times x. So I'm going to say 0.25 times x, and this will tell us how much money Josie has in quarters. And then plus how much money Josie has in dimes would be 0.10 multiplied by the number of dimes she has, which is x plus 2. And all of her money totals up to $2.30. Okay, so now we just look through the answer choices here, and we're going to see that this is going to match up with choice 3. Question 3, if g of x equals negative 2x squared plus 16, then g of negative 3 equals... And for this one, I'll do this without a calculator first, and then we'll see how to use the calculator. So g of negative 3, what I do is I just put parentheses in place of all the x's to the right of the equal sign. So we have negative 2 times blank squared plus 16. And for x, we're plugging in negative 3. So we're going to go negative 3 in this location here. And now we just have to know order of operations if we're doing this by hand. We do parentheses exponents first. So we're going to have negative 2 times negative 3 to the second power is negative 3 times negative 3, which is positive 9. And then we get plus 16. But now we work this out. Negative 2 times 9 is negative 18. So we get negative 18 plus 16. And this sum here works out to negative 2. So choice 2 is our answer. The other way to do this would be to go to the y equals and just type in the original function g of x. So we have negative 2 times x squared and then plus 16 at the end. And for this, I could press second graph and go to the table and look at what's going on when x is equal to negative 3. The y value there is equal to negative 2, which matches choice 2. Question 4, what are the zeros of f of x equals x squared minus 8x minus 20? And for this one, first I'll do this without a calculator. When we're looking for the zeros, we're setting the function equal to 0 and solving. And when you have a quadratic equal to 0, one thing you could try first is factoring. So we look for 2 numbers that have a sum of negative 8, and the 2 numbers also have to have a product of negative 20. So if you think about this for a moment, you're going to have the 2 numbers here are going to be negative 10 and positive 2. And before I go ahead and go forward from here, I just do a quick mental check. I say negative 10 plus 2 is negative 8, and negative 10 times 2 is negative 20, so I know these factors are good. And then when you have the product of two factors equal 0, you could set each factor equal to 0 and solve. So x minus 10 equals 0 when x equals 10, and then the second factor, x plus 2 equals 0 when x is equal to negative 2. And I get this just by subtracting 2 on both sides. So 10 and negative 2 are the zeros or the roots of f of x. But for something like this, you could just go to the y equals and type in the function. So we have x squared minus 8x, and then we have minus 20. And we look at all the answer choices here, and we want to see which one represent the zeros of our function. So we press graph, and notice that we have a root at negative 2 and a root at positive 10. If this is bothering you, like, wait, I can't see the graph here, you could go to the window and you could move the x maximum out to, let's say, 20. And, let's say I want to bump the y minimum down to negative 20 and y maximum up to, I don't know, let's say 60. Just make the window bigger. And now we could see more of the quadratic. Like maybe I drop this down again to, like, let's say negative 40. And now I could see the whole picture here. So negative 2 and 10 are the zeros. Question 5, which point lies on the graph of y equals 3x squared minus 1/4 x plus 3? For this one, I would type the whole thing in the calculator. So we're going to go here to the y equals, and we write y equals 3x squared, and then minus, and when you want to put a fraction in, I'll show you this trick. You could press alpha x if you have a newer calculator. Otherwise, what you do is you press alpha y equals enter, okay? And you have 1/4. So we have this. We go to the right and press x, and then plus 3. And now we just look at the table here and see which of these. All right, now if your calculator is reset, you're going to get all these fractions here. So what you could do is you press mode, you go to answers, and you switch from auto to decimal. Okay, so at the start of this video, the calculator was reset, and I do that so that I could show you how to navigate. So now we go to the table here, and we look and see which of these points is valid. And notice when x is negative 2, y is 15.5. Choice 1 is looking good. The other answer choices are no good because when x is negative 1, we should have 6.25, not this. And then at 1, we should have 5.75, not this. And at 4, for choice 4, when x is 2, we should have 14.5, not 15.5. So choice 1 is our answer. So once again, when x is negative 2, y is 15.5, choice 1. Question 6, given f of x equals x squared and g of x equals 8x minus 15 graphed on the same set of axes, which value or values of x will make f of x equal g of x? So for this one, I'll do this without a calculator first. If we want to see when is f of x equal to g of x, we could set f of x and g of x equal to each other. So we could say, I'll write this over here, x squared equals 8x minus 15. And when you're solving a quadratic equation like this, you want to move everything to one side so that you have 0 on the other side. So 8x minus 8x will cancel. On the left side, now I have x squared minus 8x, and we're left with a negative 15. And now I just go plus 15 on both sides. And I now accomplished what we needed. We have x squared minus 8x plus 15 equals 0. So now that we have the quadratic equals 0, we could factor. And the two numbers here that add up to negative 8 and multiply to 15 are negative 5 and negative 3. So this factors nicely as x minus 5 times x minus 3 because, once again, negative 5 plus negative 3 is negative 8. And the product of negative 5 and negative 3 is 15. Now, this first factor, when we set it equal to 0, gives us a root of x equals 5. And the second factor, set equal to 0, gives us x equals positive 3. So we'd have two solutions here, 5 and 3. So choice 3 is our answer. But of course, for something like this, you could just go to the y equals and type in both functions. So we have x squared is our, for f of x, and g of x equals 8x minus 15. So we type this in. I'll press zoom 6 to put the graph back to normal here. And this could be hard to see. That's why this question maybe is a little tricky. But what I could do is I want to see what's going on in this neighborhood here. We press second graph, and notice here that the y values are jumping up really high into the 60s. So maybe when I go to the window, I'll make my y maximum something like, let's say, 80. And now I press graph, and you see how we could see a little bit more? So what I could do is I could press zoom number 1, so zoom box, and I'll also show other ways of getting the exact points here, but I just want to get a better picture. So enter, and then I scroll down, and I scroll over, and then I just press enter again, and it's only going to show this part. So see how when x is equal to x equals 3, we have a point of intersection, and x equals 5. If we want to be 100% sure, press second trace number 5 and see where these graphs intersect. And you go up to the point of intersection and press enter 3 times. See, x equals 3, y equals 9 is one of our points of intersection. So the x value 3 is checking out. And if I press second trace 5 again, then it'll bring me to the other, I'll go to the other point of intersection, press enter 3 times, and x equals 5 is the other one. If I press second graph and go to the table, notice when x is 3, the two functions have matching y values, and when x is 5, the functions once again have matching y values. But the reason why I like the trace feature is if the answer turned out to be a decimal, it's hard to see those values in the table, so tracing is a very strong option. But either way, we're getting choice 3. Question 7, which trinomial is written in standard form and has a constant term of 5? So for this question, this is all vocabulary. We have to know that a trinomial is a polynomial with 3 terms. So all of these answers have 3 terms. Standard form means that the polynomial is in descending power order. That means the highest powers are in front and the smaller powers are going to the right. So I could just look at something like choice 2 and cross this off, because in standard form, this would be 6x to the 4th going first, plus 2x squared, and then plus 5. Okay, but that's not how this was written, so this is out. And all the other answer choices are written in standard form. However, the only one of those that has a constant term of 5 is choice 4. The constant term is the lone number at the end, okay, without the x's attached. Okay, so this here represents the constant term. Okay, so the constant term is the number at the end of the expression. So choice 4 is our answer. Question 8, when solving x squared plus 6x equals negative 8 for x, a student wrote x squared plus 6x plus 8 equals 0 as their first step. Which property justifies this step? So let's say for this one, you forget what all this stuff means, but you have an idea of how the student went from this to what we have over here, to x squared plus 6x plus 8 equals 0. So think about, how do you go from this to that? Well, we would have to go plus 8 on both sides. Okay, so if we add 8 to both sides, we get x squared plus 6x plus 8 equals 0. But notice we added something to both sides. And the only answer that mentions addition is choice 4. So the addition property of equality is our answer. Okay, it's not the other answer choices, because 0 property of addition just says if I take a number like 5, let's say, and I add 0 to it, the 0 property of addition just says like, hey, when I add 0, I get the same thing. Commutativity just means if I switch the order, like let's say I have 1 plus 2 equals 3. If I switch this, 2 plus 1 equals 3 is also true. And then associative property just means that the way I group things is not super, that groups could be moved. So if I do A plus B and then plus C, that's the same thing as doing A plus and then B plus C. Okay, so that's not what's happening here, so choice 4. Question 9, the tables below show the input and output values of 4 different functions. Which table represents a linear function? So for a linear function, just know that you have a constant rate of change. Okay, so this is the $1 million idea for linear functions, a constant rate of change, which means that the x values, as they increase by the same amount, the y values increase by their own same amount. Okay, that you are rising and running by the same amount to get from one point to the next. So I first look at all of the x columns. So you see how in all of the answer choices, the x's are going up by 1. So they're not like throwing any, they're not throwing anything sneaky your way. The x values are increasing by the same amount for everything. So let's really just pay attention to the y values. So from 6 to 1, that's subtracting 5. But then from 1 to negative 2 is a difference of 3. We're subtracting 3. So you see how we're not subtracting the same amount each time? That tells us f of x is no good. So this function f of x is not linear. And if we look at g of x, see how we're going here from 3 to 2 is minus 1. From here to here is minus 1. From here to here is minus 1. Now don't stop here and be like, oh, cool, it's probably this. Because here from 0 to 1, we're going up 1. Okay, and then up 1 again. So not a constant rate of change. So this one here is out. And now we look at the others. From -1 to -2, we're subtracting 1. But then we're going from -2 to -4, which is subtracting 2. So h of x is out. By process of elimination, it has to be j of x. But let's see. From -11 to 7, from -11 to -7 is adding 4. From -7 to -3 is adding 4. And then you could see -3 to 1 is +4. Plus another 4 brings us to 5. And 5 plus 4 brings us to 9. So constant rate of change here. What you could also do is you could use the scrap paper in the back of the test and just draw this out. So let's say, you have 3 hours to take the Regents. You could just plot these points and see which ones form a straight line. And it's going to be choice 4. Question 10, what is the solution set to the equation 3x squared equals 24x? So for something like this, when we have 3x squared equals 24x, there's one thing you have to be very careful of. I see students do something like this all the time. They say, oh, let me divide both sides by 3x. And then on the left side, you get x equals. And on the right side, 24x divided by 3x, they say is x equals 8. And they go ahead and they choose choice 1. But choice 1 is a very dangerous bear trap, okay? When you are solving for x and you have an equation that has a power of 2 or higher, you want a factor to solve, okay? So when I have 3x squared equals 24x, what I want to do is I want to move everything to one side. And what I get is I'm going to get 3x squared minus 24x is equal to 0. And then I factor out a greatest common factor here. So I'm going to take out a 3x, and then I'm going to divide each of these terms here by 3x. 3x squared divided by 3x is x, and then I have minus 24x divided by 3x is 8, and this is all equal to 0. And now I set the first factor equal to 0. 3x is equal to 0 when x equals 0. And then I get x minus 8 is equal to 0. This is true if I add 8 to both sides when x equals positive 8. So we actually have two solutions here. We have 0 and 8. So choice 2 is our answer. But of course, for something like this, we could go to the y equals and we could type in 3x squared on the y1 spot. And then in y2, we could put the right side of the equation 24x. And then all we have to look for here is when these graphs intersect. So I'm going to press zoom 6 to put this back to normal. And we might say like, all right, I only see what's happening at 0. And that's because 24x is climbing up very, very quickly. And so is 3x squared. So maybe for this, I don't know, I bumped the y maximum up to, let me just do 200, like a really big number. And see, all right, now see how we could see what's going on here? So at x equals 0 and x equals 8, we have a point of intersection. Now, I know at x equals negative 8, we're not going to have a solution because this graph, the quadratic is going up and the line is going down. Okay, but if we wanted to, we could also press second graph and go to the table and see at x equals negative 8, the y values are different. But at x equals 0, we have matching y values. So see here at x equals 0, matching y values, and at x equals positive 8. So at x equals positive 8, we have matching y values of 192. Question 11, the table below shows the radioactivity level of a substance after the given time t in seconds. What is the average rate of change in radioactivity level over the interval 1 is less than or equal to t, which is less than or equal to 3. So for this one, we're looking for the average rate of change. And the formula for, I'll abbreviate average rate of change like this. The average rate of change of a function, so let me say f of x, on the interval ab. This is the formula to know. It's f of b minus f of a over b minus a. But really what this is, in simpler language, this is just the slope. Okay, so what we do for a question like this is we're looking at the interval is from 1 to 3. So I go, okay, at 1 and at 3, these are my y values that I'm dealing with. And now I just find the slope here between these 2 points. So what I'm thinking about here is if I had a graph, when t is equal to 1, we have a y value of 10. And when t is equal to 3, we have a y value of 2.5. We're basically just finding the slope of this line segment here. Okay, so we're going to do the difference of, these are, the f of x values are also known as like the y values. And then when we do b minus a, these are like the x values. Okay, but in this case here, we're not using x, they're using t for time. So we just use the same concept though. So we're going to do 2.5 minus 10. See, I'm subtracting the y values and I'm dividing by the difference of the x values, 3 minus 1. So this one, 2.5 minus 10, is going to give us negative 7.5. And then we're dividing by 3 minus 1 is 2. So then negative 7.5 divided by 2 is negative 3.75, which matches up with choice 2. If you want to see how to do this on the main screen of the calculator, we press second mode to go back to the main screen here. And I'm going to press alpha y equals enter to pull up a fraction. And then I just do 2.5 minus 10, and I'm dividing by 3 minus 1. Now, the reason why I like to use alpha y equals enter is I see students make mistakes like this all the time. They just go 2.5 minus 10 and then divided by 3 minus 1. And they get something different and they're like, oh no, like, how do I do this? If you're going to do this without, writing the fraction format, you'd have to put parentheses around everything. So 2.5 minus 10 would go in parentheses, divided by another set of parentheses, and then 3 minus 1. And if you do it this way, you're still going to get negative 3.75. Question 12, Fred recorded the number of minutes he read each day from Monday through Friday. His results are shown in the table. And in this table, we have the days and the number of minutes read. And we want to know what is the correlation coefficient to the nearest thousandth and the strength of the linear model of these data. So this type of question is all calculator work. And I just want to point out that for this, you want to go to mode and make sure stat diagnostics is on. Okay, so I reset this calculator, which puts stat diagnostics off. And this is so that when we make the linear regression model that we actually get the correlation coefficient. So now I go to stats and I press edit and I go to my table. And first I'm going to put in 1 through 5. So we have 1, 2, 3, 4, and then 5. And then we go up to the second column, L2, and we type in these minutes read values. So we have 12, then we have 16, 19, 27, and 29. Okay, and then once I have everything typed in, I go to stats, go to the right to calculate. Linear regression is number 4, and I just press enter all the way through calculate. So we're looking for the correlation coefficient, which is the R value here, and we're going to round first to the nearest thousandth. So we look to the thousandths place is a 3, to the right is an 8, which tells us to round up. Okay, remember, if the number to the right is 5 or higher, you round up. If it's 4 or lower, you round down. So R, we're going to say, is equal to 0.98. And once again, we're rounding up, so we're going to bump 3 up to 4. So right away, I could see these answer choices are out. But now the question is this strong or weak? Well, just know with correlation coefficients, we have a range here of -1 to 1, zeros in the middle here. And for any correlation coefficient that is close to 1 or -1, we call that a strong correlation. Okay, so if it's close to -1 or +1, it's strong. As it moves away, it gets weaker. And if you get to 0, then there's no correlation. Okay, so this is the idea behind these questions. So something like R equals 0.984 is very, very, very close to 1. So that would be considered strong. Okay, and really what that says is that the equation of the line that we write, so this is not part of the question, but a little bit extra. If I write out y equals ax plus b, and I get y equals 4.5x plus b equals 7.1, that just means that this line is going to be a pretty strong predictor of what's going on in this data set here. That if I wanted to know how many minutes Fred is reading, at any given time during the week, that this line will give us a pretty accurate representation of the number of minutes read. Question 13, given f of x equals x squared, which function will shift f of x to the left 3 units? So just know, anytime you have a function f of x, if you go to f of x plus c, this sends you c units to the left. If you have f of x minus c, this sends you c units to the right. If we have, I'll write this over here, f of x plus c sends you c units up, and then f of x and then minus c on the outside sends you c units down. Okay, so if you just know these rules, you could go through something like this and say, okay, left 3 units would tell me to look at this one over here. So if I want to go left 3 units, that would be f of x plus 3. And I would replace the x with x plus 3 and get x plus 3 in parentheses squared. And then I can name this function anything else. So let's say k of x equals x plus 3 squared. And I just know this is going to be choice 4. But let's say you're at the Regents and you forgot those rules, or you just want to check your answer. you could take x squared as your starting function. We call that the parent function, the one when there's nothing else attached. This is the original, and then everything else is just sort of a variation of the original. And then from here, like let's say I get to choice 4, and I type in parentheses x plus 3, close parentheses, squared, and I graph both of them. And I'm going to press zoom 6 to put this back to normal. Notice that the blue one, f of x, was in blue, and x plus 3 squared is in red. That the red one is taking the blue one and sending it to the left 1, 2, 3. Okay, so choice 4 is looking good. If I type in one of the wrong answers, like let's say instead I typed in choice 3 and I have x minus 3 in parentheses squared, which is a very common mistake because when people hear left, they think minus. So they just quickly choose choice 3 without actually investigating. But notice this actually sends the original graph to the right 3 units, not left. Okay, so choice 4 is definitely correct. Question 14, a class of 20 students was surveyed to determine the number of pets each student owned. The data are represented in the dot plot below. Which statement about the data is correct? So for this one, I would just do this all in the calculator. I'm going to press stats, edit, and I'm going to clear out the second column here. And for the first column, I'm just going to type in these values one at a time. Since there's only 20 values here, this is reasonable to type in. So we have 0 showing up once. And then we have 1 showing up 4 times. So I'm going to write in 1, and I'm going to repeat it 4 times like this. Okay, so here's the values for 1. And then we have 2 showing up. It looks like, let's see, 1, 2, 3, 4, 5, 6. So I'm going to write 2 6 times. We have 1, 2, 3, 4, 5, and 6. And then 3 shows up 4 times. So we could do this. And we're here. And then 4 shows up 3 times. And then 5 shows up twice. Okay, so we have 5 showing up once, twice. And notice the last time I write in 5, that's my 20th entry. So that's how I know I typed this in right. So now I go to stats, calculate, one variable statistics. And I press enter through calculate. And this gives me all the values that we need here. Okay, so we have the average, we have the interquartile range we could find with this stuff, the median. So now we just go ahead and answer the question. So I'll write down all these significant values here. The mean is the average, and this is matching up with this piece here. So the average is 2.5. And then next we have the mode. The mode is the one that shows up most frequently. And you see how the mode here is going to be 2. Okay, so the mode is equal to 2. And then the median, we're told also, the median here is equal to 2. And it's really just the mean, median, and mode that's showing up. So you see how the mode and the median are equal to each other. Okay, so the mode and the median are the same is going to match up with choice 2. The mean and the median are different. 2.5 and 2 are not the same. The mean and the mode are different. And all 3 of them are not the same. So this choice is out. So it's definitely going to be choice 2. Question 15, the range of f of x equals absolute value of x plus 2 minus 5 is... And for this one, we could sketch this by hand, but I'll go ahead and use the calculator to graph this. So we go to the y equals, and for this one, I'll clear out the other 2 functions. And absolute value, we press math, we go to the right over here, and we press 1 for ABS is absolute value. Inside the absolute value, we have x plus 2. We hit the right arrow to get out, and we write our minus 5. Okay, I'm going to press graph here, and this is a sketch of our absolute value function. And if I press second graph here and I go to the table, this will give us an idea of which values we are dealing with, okay? Like the range here of y values. So we'll go ahead and look at each piece side by side. So since we're looking for the range of f of x, the range is the possible y values, okay? So we're focusing on the y values. And when I look for the range, I try to look for a lowest or highest point, okay? So I ask myself, is there a lowest point? Is there a highest point? And when you look at this graph of absolute value, you could see that we're in the case here where we have a lowest point. The lowest point is going to be at y equals -5, which is supported over here by the table. You see when x is -2, so when x is -2 over here, the y value is -5. And then all the y values after this are higher up. So this tells us that the range, what are the possible y values? We have a lowest point. The y values of this graph are all either equal to -5 or above. So the y values are greater than or equal to -5, which tells us choice 1 is our answer. Question 16, which equation is always correct? So the main exponent rules to know are a to the b times a to the c equals a to the b plus c. When you multiply exponents that have the same base, you add the powers together. When you have a to the b over a to the c, this equals a to the b minus c. So this tells us when we divide exponents with the same base, we subtract the powers. If you have something like a to the b to the c power, then you would multiply powers and have a to the b times c. So these are the three most popular rules that show up for exponents. But in this question here, we're actually going to have another rule to be mindful of. But let's see how far these get us. So for choice 1, this is no good because if we do a to the third times a to the x, that's going to equal a to the 3 plus x, not a to the 3 times x. So that's not always going to be correct. If we have a to the 4th to the x, that's the third rule, it's not going to equal a to the 4 plus x. It should equal instead a to the 4x power. We would multiply 4 times x and get 4x. So this one is out. And let's say I'm like, oh no, I don't know this rule. So I go to the next one. A to the x times b to the y. I can't add these powers together because these bases are different. Okay, we have different bases here. So we can't just go ahead and add x and y, and only for the base b and not for a. So this is like just wrong for a lot of reasons, okay? This is not always correct. So by process of elimination, it needs to be this one. But the idea for this one, this is its own rule in algebra. A times b as a base to the same power c is equal to a to the c times b to the c. And if I just came up with a random example, like let's say xy to the third power, this, if I expand it, is xy times xy times xy, which would be equal to, I could use the commutativity of multiplication to say x times x times x, and then times y times y times y. Let me just clean that up a bit. So times y once more. And then when I do x times x times x, that's x to the third. And y times y times y is y to the third. So you see how when I get xy in parentheses to the third, that's x to the third, y to the third. So that's the idea for that rule. And that's why choice 3, ab to the x equals a to the x, b to the x is always correct. Question 17, the formula for the area of a trapezoid is a equals 1/2 height times base 1 plus base 2. And the height h of any trapezoid may be expressed as, and we have these 4 options to choose from. So for this question, we are solving what we call a literal equation, and we're going to solve this equation for h. Now, what makes this topic a little bit tricky is that when you solve an equation like this, the variables don't cancel out. They just move to the other side. So you have all of the original letters that you started with in your final equation. So when we have this to start, I just think about what would be the easiest piece to move if my goal is to solve for, in this case, h. Well, one thing we could do right away, I'll just make space, is we can multiply both sides by 2. Okay, multiplying both sides by 2 would get the 1/2 to cancel out. So I could say times 2 on the left and the right side. And now 2 times 1/2 cancels out. And in the next line, we would have 2a equals h times base 1 plus base 2. Now, from here, let me just clean this up a bit. It's tempting when you see parentheses to distribute, but think of what the goal is. The goal is to solve for h. So let's think about how is h attached to b1 plus b2. These terms are attached by multiplication, and the opposite of multiplication is division. So we could just divide both sides by the factor b1 plus b2, and that's going to help us solve for h right away. So now b1 plus b2 cancels out on the right side, and I'll just write the result over here. We're left with h equals 2 times a over b1 plus b2, and this is going to match up with choice 1. Question 18, 3 functions are given below. So we have f of x, g of x, and then we have a table of values for h of x. And we want to know which functions have the same y-intercept. So for questions like this, the thing that I think about is I think about when I have a y-intercept, one thing all y-intercepts have in common is that the x value is equal to 0. Okay, so usually for lines, let's say we say y equals mx plus b, and the b value represents the y-intercept. So for a y-intercept, the y value is b, but the x value is 0. Okay, so for these, if I want to find the y-intercept, I just plug in x equals 0 for all of these. So let's say I do this by hand. So I'm going to write f of 0. So I plug in x equals 0, and I get negative absolute value of 0 plus 2, close the absolute value, then plus 7. And this gives us negative absolute value of 0 plus 2 is 2, plus 7. And for this one, the negative is on the outside of the absolute value. So we would get negative, and then we have, basically think of this as negative 1 times absolute value of 2 is 2. And that would give us negative 2 plus 7, which is equal to 5. So the y-intercept for f of x is 5. And now I do this for g of x. So I'm going to plug in x equals 0. Okay, so the idea is we just plug in x equals 0 for all of these. So g of 0 would give us 0 minus 3 in parentheses squared, and then minus 4. So g of 0 equals negative 3 in parentheses squared minus 4, which gives us 9 minus 4, which is also 5. Okay, so you see how g of 0 is 5 tells us the y-intercept for f of x and g of x is the same. So which functions have the same y-intercept? We could just say f of x and g of x right away. But let's see why h of x is no good. Well, for this, we don't actually have to simplify like this. We just look and see when x is 0, the y value is negative 3. So this y-intercept of negative 3 is different from the others. So that's why h of x is out. Now, I just want to point out that you could also just plug this into the calculator. So we have negative math, and then we go to the right to absolute value. And then inside the absolute value, we have x plus 2. And then we go to the right and write our plus 7. And then for g of x, we have x minus 3 in parentheses. And this is being squared, and then minus 4 outside. And if we press graph here, notice that the graphs hit the y-axis at the same point. And if we press second graph and go to the table, when x is 0, we get a y value of 5 for both. So f and g definitely have the same y-intercept. Question 19, the sum of x plus 7 squared and x minus 3 squared is, and for this one, we could do this without a calculator first. Now, one thing you have to be very careful of. I see students do stuff like this all the time. If they have to find the sum of something like this, so they're adding these, I see them go x squared plus 7 squared is 49, and then they go plus x squared is x squared, and then negative 3 squared is 9, and then they get 2x squared plus 58. But we have to be careful here. Choice 1 is a very dangerous bear trap, okay? When you're doing something like this, you're not going to just square the first and last term. You actually have to distribute this out. So x plus 7 times x plus 7, if we work this out, is x times x is x squared. But then we get x times 7 is 7x. And then when we distribute this 7, we get 7 times x is 7x, plus 7 times 7 is 49. So we actually get this middle term here. So we get x squared plus 14x, and then plus 49. And if we do this for x minus 3 squared, so x, I'll work this out over here, x minus 3 times x minus 3 is going to give us, we'd have x times x is x squared, and then we have minus 3 times x is minus 3x, and then minus 3 times x is still minus 3x, and then negative 3 times negative 3 is positive 9. And that gives us x squared minus 3 is minus 6, so we get minus 6x, and then plus 9. So when we find this sum here, what we're actually doing is we're adding x squared plus 14x plus 49. So we're adding this, and we're also adding x squared minus 6x plus 9. And for these, I like to write the like terms vertically aligned like this. So now 49 plus 9 is 58. And then we have 14x plus negative 6x is the same thing as 8x. And then x squared plus x squared is 2x squared. Okay, so that middle piece needs to be there. It should be 2x squared plus 8x plus 58, choice 3. But let's say you're in the multiple choice and you're like, that's way too stressful. What you could do is you could just type this into the calculator. So you have x plus 7 squared, and then you're adding x minus 3 squared. Okay, so you'd actually have to know that you're adding these two expressions together. And then in the y2 spots and on, you just start typing in the answer choices. So if I type in the correct one here, so we have 2x squared, and then plus 8x, and plus 58. When we go to the graph here, so this, we're like, oh no, I can't see anything. But if we press second graph and go to the table, notice how the y values all match here. And if I want this graph to actually show up, I could just make my window go way higher. Like let's say I go up to 1,000. for my y maximum. And now I could see the graphs overlapping here. So choice 3 is definitely correct. Question 20, the product of 2 square root 10 and 3 square root 2 is, and we have these 4 options to choose from. So when we're doing something like this, we just have to be very careful. When we do 2 square root 10 times 3 radical 2, because product means multiply, we have to make sure that we're multiplying the pieces that could actually be multiplied together. So we could only multiply this 2 with this 3, and we could only multiply this 10 under this square root with the 2 under this square root. Okay, the big idea for this is to know that when you have something like radical a times radical b, this is equal to radical a times b. And we do this when a and b are greater than or equal to 0. Okay, so this is when a is greater than or equal to 0 and b is greater than or equal to 0 that we use this. So when I simplify this, I do 2 times 3 is 6, and then square root 10 times square root 2 would make square root of 10 times 2, which is going to give us square root of 20. And then we look and we're like, oh no, my answer is not there. So what we do for this is we could simplify square root of 20. And the way you simplify is you break this down using this idea again. But when I choose my factors, like I wouldn't want to say 20 equals 10 times 2, because 10 is not a perfect square and 2 is not a perfect square. I would want to go with 4 and 5 because 4 is a perfect square. So I would call this not 4 times 5, I would call it square root 4 times square root 5, because once again, the 20 is under a square root. And now if we look at this piece over here, see how this piece, the square root of 4 is a perfect square. So this now simplifies to we have 6 times 2 and then times square root 5. Okay, so I just want to point out the square root of 4 is 2, and that leaves the square root nicely. So now I just do 6 times 2. This I can multiply and I get 12 square root of 5. And this is going to match up with choice 1. But once again, we're in the multiple choice. And for this one, we could also just use a calculator. So I'm going to write in parentheses 2 square root of 10. So I have 2 square root of 10. I'll exit and close the parentheses and then open a new one for 3 square root of 2. In math, parentheses means multiply. So that's why I'm just putting, we have these 2 pairs of parentheses, which tells the calculator to multiply these 2. Then I press enter and I get this decimal here. And then what I could do is I could just start typing in all of the answer choices. So like 12 square root of 5 matches. So right away, that's our answer. 5 square root of 20 is not going to match. So that's not the answer. 24 square root of 5 is not going to match. See, this is too much. And then 5 square root of 12 is also no good here. This does not match. So just by plugging into the calculator, also choice 1. Question 21, when 6x to the third minus 2x plus 8 is subtracted from 5x to the third plus 3x minus 4, the result is. Now, for this one, we just have to be very careful. The phrase subtracted from tells us that we have to switch these before we subtract. Okay, so we're subtracting this thing from this one. So we're doing 5x to the third plus 3x minus 4. And we're subtracting, I'll put in parentheses, the 6x to the third minus 2x plus 8. Okay, the parentheses here are very, very, very important. Okay, because one of the most common mistakes is students forget to distribute the minus, and it just throws the whole question off. Okay, so I'm just going to write this now vertically aligned. So we have 5x to the third plus 3x minus 4. And when I distribute the negative, I have a minus 6x to the third. When I send the negative through to this, I have minus 2x becomes plus 2x. And then minus positive 8, I just write as minus 8. And now I could combine stuff. Minus 4 minus 8 makes minus 12. And right away, the only one with the minus 12 is choice 3. But then I have 3x plus 2x is plus 5x. And then 5x to the third minus 6x to the third is minus 1, or just minus x to the third. So choice 3 is definitely our answer. If you want to check your answer to this question or just answer all of it in the calculator, you could just do 5x to the third. And then you've got plus 3x minus 4, and we're subtracting with parentheses here 6x to the third power minus 2x and then plus 8. Okay, then I close the parentheses, and in the y2 spot, I'll just say I plugged in everything, and now I get to our correct answer. We have minus x to the power 3 and then plus 5x and minus 12. Okay, so I press graph, and you see how both graphs overlap. I'll press zoom 6 to put this back to normal, but the graphs overlap. Second graph shows us that the y values match for each value of x. So choice 3 is definitely correct. Question 22, 3 relations are shown below. So we have Roman numeral 1, 2, and 3. And we want to know which relations represent a function. So you have to know that for a function, that each input has one output. Okay, so for each x has exactly one y value. So for Roman numeral 1, notice that none of the x values repeat. So that means all of these x's are going to their own place. So Roman numeral 1 is good because we have no repeating x values. Okay, so no repeating x values. Something that would be bad, and once in a while they ask questions like, which point, if added to the set, would make this relation not a function? So if I had something like, let's say 0, 2 added, then we would have a situation where in the x column, we have 0 going to 2 places. It goes to 1, and then it goes to 2. And we can't have an x value going to 2 different y values because then this would not be a function. Okay, but that's not the case here. So we could say that Roman numeral 1 is good. Now notice Roman numeral 2 is good because all of the x's are going to one place in the y column here. So there's no repeating x values here. If we had something like this drawn in, where we have 2 arrows leaving the x column to the y column to 2 different y values, that would be no good. But that's not the case here. So 1 and 2 are fine, which means this answer choice is out and this one is out. So now the last thing to do to determine if your relation represents a function is you use the vertical line test. And the way the vertical line test works is if you had something like, I'll draw something that's not a function of x. So let's say I had a circle. So let me just make this a little bit neater. So if we had a circle, something like this, a circle is not a function of x because if I drop down a vertical line in this location, it hits the graph twice. Okay, it's not like you can't just say like, oh, I drew my vertical line over here and it didn't touch at all, so it works. It's any vertical line that you draw. If at any point you draw a vertical line and it hits the graph twice, then the graph does not represent a function. So here, this question here, they made it a little bit tricky that the vertical lines here, let me just straighten this out. If we look, you might say, oh wait, it's hitting the graph twice. It's hitting it here and here. However, the sneaky detail to look out for is that the circles, some of them are open. So you see how like this one is open, and over here I can even say this one is open. So when I put my vertical line, if the vertical line lands on an open and a closed circle, it only counts as hitting the graph once. Okay, so here, see how it's hitting an open and a closed, so that's hitting once. So actually all 3 of these work. Okay, so all 3 of them would represent, let me just go back to purple here. All 3 of them would be relations that represent a function. If I want to turn the third one into something that's not a function, if one of these points here were closed like this, then when the vertical line is drawn in like this, see how it's hitting 2 closed points, and this would not count as a function anymore. Okay, but that's not the case. Okay, notice that once again, we are open at this location, so all 3 work. Question 23, the method of substitution was used to solve the system of equations below. And then the question is, which equation is a correct first step when using this method? So when we're using substitution, I'm going to write it over here. The first step is to solve an equation. So we solve an equation for x or y, okay, for x or y. And then the second step is you plug that in. So you plug that equation in. So I'll just say you plug in to the other equation. Okay, so that's what we do when we solve a system by substitution. So the one that looks easier to solve is the bottom one. See this one over here? So the easiest way to solve this is to solve it for x. So if I have x minus y equals -1, I could solve for x by just doing plus y on both sides. And now this gives me, I'll say over here, x equals y, and then I have -1. So x equals y minus 1 would be the correct first step, solving for x or y. Now you might be thinking, wait a minute, what if I solve for y instead? But solving this for y would give us something a little bit different. If I start once again at x minus y equals -1, to solve for y, I go minus x on both sides. And then this cancels, and I'll write the result over here. We would have minus y equals minus x minus 1. And now from here, what I could do to solve is I can multiply both sides by -1. In algebra, if you put parentheses around the whole equation, that's one way to say you're going to multiply everything by the same value. So if I multiply minus y by -1, I get plus y equals plus x plus 1. So y equals x plus 1 would be another correct answer, but they wrote y equals x minus 1, so this is out. So definitely choice 1. Question 24. In 2009, Usain Bolt, a sprinter from Jamaica, set the world record in the 100-meter dash with a time of 9.58 seconds. His approximate speed in kilometers per hour can be found using which conversion? So for these questions, what I look for is the units that we want at the end. Okay, so at the end, what we want is kilometers per hour. All right, that's the goal. But to help students understand this, what I like to do is I like to talk about height in feet to inches. So true story, I am 6 feet tall. And then I ask my student, I'll usually ask my students for this, how many inches tall am I? And they'll say, oh, times 12, you are 72 inches tall. But I say, okay, 6 feet times 12 equals 72 feet. So I'm 72 feet tall. And then they're usually like, no, that's crazy. No, that's not what we meant. We meant times 12 inches. So say, oh, okay, 6 feet times 12 inches is 72 feet inches. And I do this purposefully to get them to think about what's really going on here. When I'm converting my units for my height from feet to inches, I'm using the idea that 1 foot equals 12 inches. So when we convert, we're not actually multiplying by 12. We're multiplying by 12 inches over 1 foot. You could see that over here, if I divide equal quantities, the quotient of equal quantities is equal to 1. Unless I'm dividing 0 by 0, but that's a totally different story. But for every other case, when you divide equal quantities, you're getting 1. So what happens is I write it this way, times 12 inches over 1 foot, and the units cancel out. See, feet above cancels out with feet underneath, and then I'm just left with inches, and I get 6 times 12 is 72 inches. So now we look back to this over here where things are a little crazier. But the big idea for these questions is when you have matching units on top and bottom, they cancel. So I go to choice 1 and I'm like, okay, seconds over seconds cancels, minutes over minutes cancels, and then here we have meters over meters cancels, and it seems like this is going to be the answer. But notice we would get some number when we multiply all this, but we would have hours on top, and we would have left on bottom is kilometers. But we want the answer in the form of kilometers per hour, not hours per kilometer. So choice 1 is almost good, but not quite what we need. And then we look at the other wrong answers. Right away, I see 2 is no good because we would have meters times meters. At the end would make meters to the second power or meters squared. So this one is not the answer because we need kilometers per hour at the end, and the meters would need to cancel out. So 2 is out. And then we look here, meters over meters cancels, and we look elsewhere and see minutes over minutes cancels. But notice here we get seconds times seconds is equal to whatever number we get by multiplying the numbers across. But we'd have in the denominator square seconds, okay, or seconds squared. So 3 is out. By process of elimination, it has to be 4, but let's hope everything cancels to give us kilometers per hour. So we have meters canceling out with meters. We have seconds canceling out with seconds, and we have minutes canceling out with minutes. And notice the units we get. We're going to get some number by multiplying 100 by 60 over 9.58 times 1,000. But the units we're going to get are kilometers in the numerator, and we're left with hours in the denominator, which gives us kilometers per hour. So choice 4 is definitely correct. So now moving on to the part 2 questions. There's 6 questions here, and each one is worth 2 credits. Question 25, we're going to solve this equation here algebraically. So we have 1/6 times 4x plus 12 equals 9. And the first thing we could do is multiply both sides by 6, because that's going to get the 1 over 6 to cancel out. So we're going to go times 6 on the left and right side. Now 6 over 6 cancels out. 6 times 1/6 is 1. So now in the next line, we have 4x plus 12 equals 9 times 6 is 54. And now just 2 more steps here. We go minus 12 on both sides. And 12 minus 12 cancels. And we have 4x equals 4 minus 2 is 2. 5 minus 1 is 4. So we get 4x equals 42. And now from this step, we divide both sides by 4. And we just say x equals. So we could just type this in. We go back to the main screen here. So I'm just going to quit past that screen, and we're going to have 42 divided by 4. And this works out to 10.5. So we have x equals 10.5 is our solution. Now, one thing I want to point out, this is a 2-point question. And let's say you have no idea how to do this algebraically. What you could do is you could do this in the calculator and get partial credit here. You could get 1 out of 2 points. So I type in 1/6 4x plus 12, and then equals 9. I'm going to put 9 on the right side. And then I press graph here. And if this is in standard form here, notice that we can't see where the graphs intersect. So I'm going to press window, and I'm going to go out to, let's say 20. Okay, so I'm going to go out even more. And now there's the point of intersection. If I press second trace number 5 for intersect, and I scroll up to this neighborhood here, and I press enter 3 times, this tells us that the graphs intersect at x equals 10.5. So you see, we could get the answer here with just the calculator, but they told us to do this question algebraically. But if we do this any other way, we do get partial credit. Just writing x equals 10.5 down will get you 1 point. Question 26 is the sum of 3 square root 2 and 5 rational or irrational? And we have to explain our answer. So for this one, we have to know a few ideas. For one, when you take the square root of a non-perfect square, like in this case here, square root of 2, square root of 2 is irrational because 2 is not a perfect square. And then if you multiply an irrational number by 3, it's still going to be irrational. But then when you do the sum of an irrational number and a rational number, 5 is rational because it's a whole number. The sum of an irrational and a rational is irrational. Okay, so just by knowing the rules, I could say, hey, this is going to be irrational because the sum of an irrational number and a rational number is irrational. Question 27, we're going to graph h of x equals absolute value of x minus 2 over the domain -4 less than or equal to x less than or equal to 4. So for this one, we could just go over to the y equals here, and we'll clear out the other stuff. And we're going to have, let's see, math. We go to the right, absolute value, and we've got x minus 2. Okay, so I'll press graph here, and I'll press zoom 6 just to put this back to standard window to see what this looks like. But we're only graphing this from -4 to 4. So if we go to the table here, second graph, we're only going to use these values here from x equals -4 all the way through x equals +4. So now we have our graph and we have this table. Now just be careful here. Students sometimes, they'll just look at this and go, oh, okay, let me just draw a V shape like this. And they just like swing in a V and like, give me partial credit. But for these questions, that would get 0 points. To get any points here, your graph needs to be precise. Okay, so really like take your time here graphing this and make sure that it's neat and that the points line up. So we have x and h of x, and we're going from -4 to +4. So my x's start at -4 and they go all the way to +4. Now you don't actually have to write this in your workspace to get full credit here. You just have to produce the graph. But I like to do this just to show, you know, what values I'm plotting here. So -4, 6, and then see how we're just going down by 1. So I'll just go ahead and do that. So we have 6, 5, 4, 3, 2, 1, 0. And then after 0, it starts going up again to 1 and then 2. So then what we do is we just plot these points. Okay, so the graph is going to go from -4 on the x to, we're going out here to 1, 2, 3, 4 in this direction here. And the smallest y value is 0. The highest is 6. So 1, 2, 3, 4, 5, 6. So we're at -4, 6. And then -3, 5, and this is just going to keep continuing to make our V shape. So I'll just label this spot over here on the y-axis as 6 so that the scale is obvious. But remember, we're not graphing the whole thing. Please don't continue this and put arrows. We're only graphing it over this domain here from -4 to 4, so this graph would get full credit. Question 28, a survey was given to 180 cell phone owners about the brand of phone they owned. The results showed that 59 adults owned brand B, and 32 teenagers owned brand A. Of all the people surveyed, 40% owned brand A. And we have to complete the two-way frequency table below. So for this, I just like to start out with what we know and then just start finding the rest. So the most obvious stuff we know is we were told here the results showed that 59 adults owned brand B. So this part here, 59 adults owned brand B. I go to brand B and then to the adults and I put a 59 here. And then we're also told, this is also very obvious, 32 teenagers own brand A. So teenagers, brand A is this space here. We're going to write 32. And then what we have is the survey was given to 180 cell phone owners. So in the total column here is going to be 180 cell phone owners in total. Okay, that's adults, teenagers, all the people that own brand A, brand B. So now the next piece of information, which might be a little bit tricky to use, of all the people surveyed, 40% owned brand A. Okay, so out of all the people surveyed, that's 180, 40% own brand A. So we're finding 40% of 180. And for this, you have to know a little bit about percents, but 40% is 40 out of 100. And of in math tells you to multiply, so we do 40 over 100 times 180. Okay, and this we could just do in a calculator, or I'll just show how to do this by hand. In math, when you have common zeros by division, you could just cross them off. So this 0 over 0 will cross off, and then the 0 here and the 0 here crosses off. And then you're just doing 4 times 18 is 72. Okay, so now we look here, of all the people surveyed, 40% owned brand A. So that tells us 72 people in total own brand A. So then now we can start finding the other pieces here. How many adults own brand A? We could do 72 minus 32. That's the total number of people that own brand A minus the 32 teenagers that own brand A. Tell us that 40 adults own brand A. And now we could start finding some other totals here. So this section over here, we could just do 40 plus 59. So I just add those, and that's going to give us 99. So there are 99 adults in total here. And now how many teenagers in total? We could do 180 minus 99. So there's a few different ways to go through with this. So we could borrow here. 10 minus 9 is 1. And then what we're doing here, 17 minus 9 is going to give us 8. Okay, so that tells us that there's 81 people here in total in the teenager section. Okay, so there's 81 teenagers. And now some of the other entries here, how many teenagers own brand B? Well, there's 81 teenagers in total. So we could just do 81 minus 32 that own brand A, and that'll tell us how many teenagers own brand B over here. Okay, so we borrow or just use the calculator. 11 minus 2 is 9, 7 minus 3 is 4, and we get 49. And now for this entry here, the total, we just add 59 and 49. So we're doing, all right, over here, 59 plus 49. We have 9 plus 9, carry the 1, and then 1 plus 5 plus 4 is 10. So we get 108. Okay, so all of these values here are good. Question 29, determine the 8th term of a geometric sequence whose first term is 5 and whose common ratio is 3. So for this one, we could go to the back of the Regents, to the reference sheet, and copy the formula down. A sub n equals, and then we have a sub 1 times r to the n minus 1. This is the geometric sequence formula, where a sub n represents the nth term. Okay, so this is the nth term. This is the first term, and r is the common ratio. Okay, so we could just use this formula. The common ratio for a geometric sequence is the number that gets multiplied each time to get from one term to the next. Okay, so here I'll write the formula first. We'll say in our case, a sub n equals the first term is 5. So they're telling us here a sub 1 is 5. So we could say a1 is 5. And then here I'll write in parentheses r, the common ratio is 3. So this is telling us the common ratio, r equals 3. So I plug it into the formula, 3, and now to the n minus 1 power. So when they tell us, hey, or they ask us, what is the 8th term, determine the 8th term, this tells us to plug in n equals 8. So n equals 8 gives us a sub 8. See the n here? I'm just going to put an 8. This means the 8th term is equal to 5 times the base 3 to the 8 minus 1 power. Okay, so I'm going, remember, n equals 8. 8 minus 1 is going to give us 7. So we have 5 times 3 to the 7th power. So I just go back to the main screen here, and we're going to have 5 times 3 to the power 7. And this is going to give us our answer. Now, one other thing I want to point out, if you just want to do this one by brute force, what you could do is you could say, all right, the first term is 5, and the geometric sequence, the common ratio is 3. So if I do 5 times 3, this gives me the second term. Times 3 again gives me the third term. and then times 3, fourth term, fifth, sixth, seventh, and then eighth term is 10,935. But when you use the formula, it's just way, way, way faster. It gets you to the answer right away. And the benefits of the formula, if they tell you to find the 800th term, you're not going to sit there, hopefully, with the calculator and multiply by 3 800 times. You would just write your answer in exponent form. Okay, so this is going to work out to 10,935. So our eighth term here is, once again, 10,935. Question 30, using the method of completing the square, express x squared plus 14x minus 28 equals 0 in the form x minus p squared equals q. So for this question here, what we could do is we're taking x squared plus 14x minus 28 equals 0, and we're turning it into this form here. Now, this could be a little tricky to do, but what I like to do is I like to get the x squared and the x term on one side, and I move everything else to the other to start. Okay, so for this, I'm just going to add 28 to both sides. And now we have x squared plus 14x, and I'm going to leave a space here, equals 0 plus 28 is 28. Now, in that space, the big idea for completing the square is you're going to have something in the form of x squared plus bx, and then plus c, but I move that other constant term here to the other side. So what you do is you take the b term, you divide it by 2, and you square it. And that number you add to both sides. So just always remember, for completing the square, take half of the b term, square it, and add that number to both sides. So in this case, we have a b value of 14. And one thing I want to point out, you use this technique when your quadratic is in the form of 1x squared plus bx. Okay, if there's not a 1 in front, then it's a little bit trickier. But for the Algebra 1 regions, you're basically dealing with these situations where you have a 1x squared. So for this, what I'm going to do is I'm going to take 14, divide it by 2, and then square it. So that gives us 14 divided by 2 is 7, and 7 squared is 49. So that's the mystery number that we're going to add to both sides. And this is called completing the square because if we do this correctly, the left side should be what we call, this is a perfect square trinomial. Okay, so it becomes a perfect square trinomial. You don't actually have to write this at the Regents. I'm just writing this down here for like instructional purposes. So now when we go to factor this, we're looking for two numbers that have a sum of 14 and a product of 49, but the number, or the numbers we're looking for, should match half of the b term. See, half of 14 is 7. So those are going to help us now write out, that's going to help us write out the factors. So we're going to have x plus 7 times x plus 7 equals, and now 28 plus 49, we could just work this out, is going to give us 77. Okay, so this works out to 77. So now x plus 7 times x plus 7 is x plus 7 squared, and this is going to give us 77. Now, one thing I want to point out about the Regents, I really didn't like this question for one reason, is they technically told us to express the answer in the form of x minus p squared equals q. But you see how our answer came out as x plus 7 squared? So for this one, this is enough to get full credit, but I mean, here they said, hey, x minus p squared equals q, which could be confusing because some kids might think, oh no, should I be getting a minus here? But if we really wanted to write this in a form that matches what they have, I could say x plus 7 is the same thing as x minus negative 7. But that just seems really silly to go this extra step here. So I won't even bother with this because according to the rubric, if we look at some of the model responses here, this is enough here to get full credit. So now we're moving on to part 3. There's 4 questions here, and each question is worth 4 credits. Question 31, we have to graph f of x on the set of axes below, and then we're going to state the vertex and state the equation of the axis of symmetry of this function. So for this one, what we could do, we could go to the y equals, and we could type this in. So we have negative, and then I'll write alpha y equals enter to make a fraction. We have 1/3. Hit the right arrow to get out of the fraction, x squared, and then plus 4. And I'll press zoom 6 just to put the graph back to normal here. And we have the graph here, but I'm going to press second graph and go to the table. And when we actually go and graph this, I just want to focus on the integer values here. So you see how we have -6, -8. I don't want to graph this one here, like the decimal values. I'm only going to graph the ones that have nice integer coordinates for x and y. So for this one, I'm going to make a table of values here for our points. But like I said before, I'm only going to use the points that have integer values for x and y. So let's say I have x equals -6. The y value there is going to be -8. And then the next one I would use is -3 for x, +1 for y. And then we have 0, 4. And then we have 3, 1. Okay, and then the last one will be 6, -8. So these are the points that I'm going to plot, and I'm going to connect them here with this parabola shape. So this graph of f of x is good, and now we can move on to the other parts here. So first we have to state the vertex. The vertex is the turning point of the parabola, and the turning point here is occurring at 0, 4. Okay, so our vertex is going to be at 0, 4. And we could even see in the table here that the values start to repeat surrounding 0, 4. So this is definitely our vertex. But now for the equation of the axis of symmetry, if we want something to visualize here, we could see that the axis of symmetry is the line that cuts the parabola in half nicely, that if we were to fold this over the axis, these pieces would land on top of each other. Okay, so our axis of symmetry is the y-axis, but we can't say the y-axis. We actually have to write an equation for it. So the equation for the y-axis is actually the line x equals 0. A common mistake is people say y equals 0, but y equals k, where k is constant. This is a horizontal line. Okay, so these lines are horizontal, but x equals a constant is a vertical line. So if the vertical line is passing through x is 0, then the equation would be x equals 0. And that would capture the equation for the y-axis. A little bit extra though, the equation for the axis of symmetry is x equals -b over 2a. And what I'm talking about when I say -b over 2a is when you have y equals ax squared plus bx plus c, the b values and a values are the coefficient of the x and the x squared. So if we look at our original equation here, it's like what we have is our a value is equal to -1/3, but our b value is 0 here because there is no x term. So if we plug that into the formula, we would get x equals -b is 0 over 2 times a is -1/3. 0 divided by a non-zero works out to 0. So we still get x equals 0 here. But for this, we don't actually have to show the work with the equation. We just have to state it. Okay, so just saying x equals 0 is enough. And this gives us full credit for question 31. Question 32, we have Vince wants to rent a canoe while he is on vacation. The canoe rental company charges $18 for the first hour and $7.50 for each additional hour X. If Vince has $78 to spend on renting a canoe, write an inequality in terms of X that models this situation. So for this first part here, this was one of my least favorite questions in this whole Regents because of how it was worded. The key detail here is that X is representing the additional hours. Okay, so for this one, when we start this off here, the constant is going to be 18. So for this, you're thinking y equals mx plus b. Okay, so y equals mx plus b. This is sort of like the fixed amount. And then this is like the hourly rate. So this is the rate, and this depends on how many hours goes by. But x represents the additional hours. So for this, we're starting off with 18, but then we're going to go plus 7.50 times x. Okay, and this is representing how much money Vince is spending, but x represents the additional hours. Okay, so this is the additional hours after 1 hour has gone by. Okay, the first hour is 18, but then the additional hours we call x. So the reason why this wasn't my favorite is it would have been, it would have been more challenging to have students do this, but what would make more sense here would be to write an actual function that would tell you how much money Vince has to spend depending on how many hours in total have gone by. But just be careful here with this wording because X is representing just the additional hours. But they're telling us here, Vince has $78 to spend on renting a canoe. So that means this is, in a way, like this whole piece here collectively, I'll highlight. This represents and let me just change colors because I went yellow for additional hours, but this represents the total money spent. Okay, so total money spent. So the total money spent by Vince has to be less than or equal to $78. Okay, so this is just how much money Vince has to spend, and this would model the situation. But once again, X represents the additional hours after the first hour. So we have to algebraically now determine the maximum number of hours that Vince could spend on a canoe. So we have 18 plus 7.50x is less than or equal to 78, and we just solve. So minus 18 on both sides. And this is going to give us 7.50x is less than or equal to 60. And now we just divide both sides by 7.50. And for this one, we could just type this into a calculator. So that I'll just like leave as an exercise. But 60 divided by 7.50 is going to give us 8. Okay. So then from here, it's what's the maximum number of hours? It's tempting to say 8, but this represents, remember, additional hours. So the additional hours is less than or equal to 8. So the maximum number of hours. So let's see, the maximum hours, we would have to account for that first hour, which was 1 hour went by, and then he could get 8 additional hours. So the maximum number of hours here is going to be 9. Question 33, we're going to graph the following system of inequalities on the set of axes below, and then we're going to state the coordinates of a point that is in the solution to the system, and we have to justify our answer. So for this one, the big idea is y equals mx plus b. So when we have y equals mx plus b, m is our slope, and when we're graphing a line using the slope, we think of slope as rise over run. And then the b value is the y-intercept, and that tells you where to begin. So this first linear inequality is already in the form we need it. So here we're going to begin at -3. So I go down 1, 2, 3, and then the slope is -1/2. So when I have a slope of -1/2, what this tells me to do, it tells me to go down 1 and then to the right 2. Okay, so I go down 1 to the right 2 like this, and I keep doing this until I run to the edge of the graph. Okay, so I'm just going to keep going like this until I get to the edge of the graph. But when I want to go the other way, I have to make sure that I keep this straight line. Instead of going down 1 to the right 2, now I could go up 1 to the left 2 like this. And you see how this is keeping that straight line that we need. And for this, the inequality says y greater than or equal to. So I'm going to connect these with a solid line like this. And because it was greater than or equal to, I'm going to shade everything above. And for these type of questions on the Regents, it's important that we label at least one of the inequalities. So I'm going to say here, this is y greater than or equal to -half x, and then -3. Now, for the second inequality, this one, we have to do one step of algebra first. So we need this to be in the form of mx plus b. So for this one, what I'm going to do is I'm going to add 2x to both sides. So we're going plus 2x on both sides, and now we have y is less than 2x plus 5. And for this, I'm going to begin at 5, so 1, 2, 3, 4, 5 on the y-axis, and this slope is +2. So that tells us we're going to rise 2 and run 1. So we go up 2 over 1, and up 2 over 1, see, that would bring me about here. So for this one, I'll just put an arrow at the end to show what's going on. So here, I'm going down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. Yeah, just a little bit more on that detail at the end. If you don't go to the end of the graph, then you have to put an arrow at the end to show that you're just going on forever. It's a small detail, but it's an annoying way to lose 1 point. Okay, so I just make sure I use that slope of 2 to get the rest. And now, because this one is strictly less than this inequality, I'm going to connect these points here with a dotted line. So I'm going to go like this, just to show that this inequality is a little bit different. It's strictly less than, which means the points on the line are not included in the solution set of this inequality. And since it's a less than situation, I'm going to shade everything under this line. Now, they didn't tell us to label our solution set, but for these questions, I do like to label the solution set S. That's where the solutions to each inequality overlap. See, this is the overlapping region. So now here, they're asking us, for the last part, to state the coordinates of a point that is in the solution to the system, and we have to justify our answer. So the easiest one I could see is the point 0, 0. So I'm going to say 0, 0, and justification means we don't have to write a sentence. It just means we have to show why this works. So my favorite way to show why is to just plug in. And maybe before we do that, to be extra safe here, I'm just going to label this one here as y less than 2x plus 5. So now both inequalities are labeled. So for the justification here, how do I know that this point satisfies both? I'm going to plug 0, 0 in to both of the inequalities here to show they satisfy both. Okay, so for justification, what I could do is I could say that for, let's say, the first one, so I'm plugging in, we have y greater than or equal to negative half x minus 3. When I plug in, I get 0 is greater than or equal to negative 1/2 times 0 minus 3, which tells us 0 is greater than or equal to negative 3, and this is true. Okay, so this is a true statement. When I plug into the other inequality, and I'll write it in original form, y minus 2x is less than 5. So y minus 2x less than 5. When I plug in x is 0, y is 0, I get 0 minus 2 times 0 less than 5, and that gives us 0 less than 5, which is also true. So that's how we know 0, 0 is a solution to the system. Now, before we move on, I want to go over here to apps in the calculator. And notice at number 7 here, we have inequals. I mean, why there's a Z, I don't know. But if we go there and press enter, and then we go over to the y equals and type in each of these inequalities. So first we have negative 1/2. So I have negative and then alpha y equals enter. And I'm going to write in 1/2. After the half, we have x minus 3. And what you could do in this setting here is pretty cool. You go over to the y1 spot, so all the way to the left. And this is a greater than or equal to. So I'm going to press enter on this. And I'm going to go down to the y where it says y equals. And we're going greater than or equal to. So I'm going to go here and then press enter, enter to set this up here. And then the next one is y less than 2x plus 5. So I'll go over to the next one. I'll go to the y equals and switch it to just a less than. And then to the right here, I'm going to write, so afterwards, I'm going to write 2x plus 5. Okay, so we have 2x plus 5. And now I'll press zoom 6 to graph this. And notice that we get exactly the shaded region that we have over here. Okay, so this is just a nice way to make sure that you're shading everything correctly. It's a fun little feature of this calculator, but our answer here definitely checks out. Question 34, using the quadratic formula, solve x squared minus 6x plus 3 equals 0 and express the answer in simplest radical form. So for this one, we could just go to the back of the Regents and we get the formula sheet, and the quadratic formula is on the formula sheet. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And when we have a quadratic equation in this form here, the a value is the coefficient of x squared, the b value is the coefficient of x, and the c value, the constant at the end, is the low number here, which is 3. So what we do is, to solve for x, we just plug these values into the quadratic formula. So when we have negative b, notice our b value is already negative. So we're really just taking the opposite of this. We could write negative negative 6, but negative negative 6 just turns to positive 6. So we're going to get positive 6 plus or minus the square root of, and then we have b squared, so we get negative 6 in parentheses squared, minus 4 times 1 times 3, and this is all over 2 times a, and a is equal to 1. So now from here, we just start to simplify this. We get x equals 6 plus or minus, and then we have the square root of, negative 6 to the second power is 36, and then we get minus 4 times 1 times 3 is 12, all over 2 times 1 is 2. So now this will bring us to, in the next line, we have x equals 6 plus or minus, and then we have the square root of 36 minus 12 is 24, and we're all over 2. But the question said from here to express the answer in simplest radical form. So I just want to point out that the square root of 24, we could do this off to the side. The square root of 24 could break down nicely to, we could call this square root of 4 times square root of 6. We could say 12 and 2, but remember, the goal when you're expressing a radical in simplest radical form is to find a perfect square factor of the original number. And 4 is a perfect square, so that's why we're going with this. And then we say the square root of 4 is 2, so we get 2 square root of 6. Okay, so this just tells us the square root of 24 equals 2 square root 6. So now we can write this out. We have x equals 6 plus or minus, and then we have 2 square root of 6 over 2. Let me just make this a little bit neater. So we have 2 square root of 6 over 2. And we could actually stop here because the question only said to express this in simplest radical form. They didn't say to do anything else after this. In other parts of math, they may say express your answer in a different form here and actually divide this out. But this is where we can stop. If you want to see this simplified a little bit more, though, because we can simplify this a bit more, we can go ahead and divide each of these terms here by 2. So we would be able to say, but I just want to point out that according to the rubric, you could stop here, okay? If you do anything else beyond this point, you are just doing this for the glory of simplifying this more, okay? But this is where you get your full credit. Anything else could only risk you or be a risk for you losing more points. So I'll just go ahead and do this though for instructional purposes, that we could say 6 divided by 2 and then plus or minus 2 square root of 6 divided by 2. And now 2 divided by 2 just cancels out. And we could say here that x equals 6 divided by 2 is 3. And we get 3 plus or minus the square root of 6. So here's our solution to this question. Now, if we want to check our answer here, what we could do is we could write 3 plus the square root of 6. So we get this decimal here. And I'm going to press store. And I'm going to store this as alpha math, the letter A. So now every time I write the letter A, the calculator is going to read it as that number. And if I were to do something like A plus 1, it would take that number and just add 1 to it. And then the other root, 3 minus square root 6, that I'm going to type in. And I'm going to store this one. I'm going to press store and store it as the letter B. Okay, so now both answers are stored. And watch what we could do with this. So I'm going to go back to the original question here. So we have the original equation is x squared minus 6x plus 3. And I'm going to do a squared. So the first answer is squared minus 6 times the first answer, and then plus 3. And notice this gives us 0. So the first answer checks out. And then if I do alpha apps to get the letter B, where I stored the second answer, I have b squared this time minus, not 5, I'm going to put 6 times b, and then plus 3. And this also gives us 0, so those answers are definitely good. So now we're moving on to part 4, the final boss. This one question is worth 6 credits. Question 35, Cameron sold hot dogs and sodas at a concession stand. He sold a total of 25 items for $45. A hot dog sold for $2.25 and a soda sold for $1.50. All prices include tax. If X represents the number of hot dogs sold and Y represents the number of sodas sold, write a system of equations that models this situation. So we'll do this part first. And what I like to do for questions like this, X represents the number of hot dogs, and a hot dog sold here for $2.25. So I like to put the X near where in the question they told us the price of the hot dog. So next they tell us that Y represents the number of sodas sold. So by sodas, I'm going to put Y. And now this is going to help us set up our system. So the hot dogs were $2.25. So I'm going to put 2.25 times X. And this represents how much money Cameron made selling hot dogs, okay? Because he sold X hot dogs for $2.25 each. So we do 2.25 times X to see how much money Cameron makes from hot dogs. And then after that, we would add the money made from sodas. And sodas are $1.50 each. And Cameron sold Y sodas. Okay, so we're going to do 1.50 times Y. And that tells us how much Cameron made selling sodas. And altogether, he sold a total of 25 items, but he made $45. Okay, so the $45 is going after this one. But this part here is sometimes a little tricky to interpret. He sold a total of 25 items. So the items are referencing hot dogs and sodas. Okay, so hot dogs and sodas. So that tells us if X is the number of hot dogs and Y is the number of sodas, then Cameron sold a total of 25 of those items. So now that we got this system set up, we could determine algebraically the number of hot dogs Cameron sold and the number of sodas he sold. So we're going to do this one here by elimination. So we have the first equation here. So we're going to have this one the original equation. And then for the second equation, what I want to do is I want to multiply the second equation by negative 1.5. And the reason why I'm doing that is I want the y terms to cancel out. Okay, so I'm going to multiply this by negative 1.5 across the bottom. So we're going to have, I'll just show this out here. We're going to have negative 1.5 in parentheses, and we're multiplying this across the whole equation here. So we have x plus y equals 25. So I'll just move all this stuff over here so we have the space. So this, we're going to go ahead and start to work out. So when we simplify this, next over here, we have the original equation on top. So we have this, and then this is equal to 45. But now on bottom, this changes a bit. We're going to have negative 1.5, but I'll put an extra 0 here, x minus 1.50y. And if I do 25 times negative 1.5, you can work that out in a calculator. You're going to get negative 37.50. Okay, so this, let me just bring this over here though so that we stay like within this space. And now we just go ahead and add these together. Okay, so we're going to add the equations together. And when we add them together, the 1.50y cancels the minus 1.50y. And if I do 2.25 minus 1.50, I get 0.75x. And now this is going to equal, if I do 45 minus 37.50, I get 7.50. And now all I have to do here is just divide both sides by 0.75. Okay, so we do this, and we could see here, we just work this out. We're going to get x equals 10. Okay, 7.5 divided by 0.75 is 10. So this tells us that x is equal to 10. But now what we could do is to solve for y, we could take any one of these equations, but the second equation is easier. So when x equals 10, this tells us that we get 10 plus y equals 25. And this will give us, we just subtract 10 on both sides, y is equal to 15. Okay, so we'll just write the answer formally here. Determine the number of hot dogs Cameron sold and the number of sodas he sold. Well, x is the number of hot dogs. So this tells us that Cameron sold 10 hot dogs. So we have 10 hot dogs and 15 sodas. Okay, so this is the amounts here that Cameron sold. And now for the last part, we have a customer has $20 to spend at the concession stand. Determine and state the maximum number of hot dogs he can purchase if he buys 4 sodas. Well, the sodas cost $1.50 each, okay? So first what we could do is we could do 4 times 1.50. And if we multiply this out, we get $6 here, okay? But I'll just write this without the units. We'll just say the maximum amount at the end. So $6 is going to be spent on sodas. Well, if the customer is spending $20, we could just do 20 minus 6 is 14, but now the cost of a hot dog is $2.25. So what we could say here is we could take the $2.25 and divide it into 14. Okay, so we're going to do 14 and we're going to divide this by 2.25. Okay, so we divide these. And this we could just type in a calculator, but if you do 14 divided by 2.25, you're going to get 6.2 repeating. Okay, so we're going to get this. But let's see here. You can't go to a hot dog stand and buy a fraction or a part of a hot dog. Okay, that's not how hot dog stands work. So the maximum number that this customer can purchase is going to be 6 hot dogs. Okay, so we're going to say 6 hot dogs. This is the maximum amount that this customer could purchase.